Welcome to the Data Leadership Lessons Podcast. I'm your host, Anthony Algman. Data is everywhere in our businesses, and it takes leadership to make the most of it. We bring you the people, stories, and lessons to help you become a data leader. We've partnered with Dataversity to provide listeners with 20% off your first training center purchase with promo code ALGMANDL. Go to dataleadershiptraining.com to learn more. Today on episode 98, we welcome Robert Cooke. Robert is the founder and principal architect at 3Forge, a New York-based provider of data virtualization and visualization technology. Robert has an unmatched passion for all things computer science and has over 100,000 hours of software development. Robert, welcome to the show.
Yeah, good to be here, Anthony. Thank you for having me on.
So pleasure to have you. Just take a few minutes and just give us the kind of story highlight of your career and how your earlier experiences led up to doing what you do now.
Okay. Well, based on your intro, the fact that I've spent over 100,000 hours coding, you can imagine I haven't done much else with my life. But but no, I actually, I guess my life story is, even when I was a little kid, once I got an understanding of even the idea of what a computer was, not really having any sort of in-depth knowledge. I knew I loved computers, and I knew I loved the idea of computers, and I wanted to learn more about computers. So ever since, writing my first basic program, that's basically been, my life has been just evolving and trying to understand and write more sophisticated and interesting programs. I wrote my first accounting software back in grade school to manage our club. And that kind of got me interested in data and what it means to manage data, and all the things that go along with that, entitlements, etc. And then I was introduced to fintech in 2000. Originally, prior to fintech, I was doing a lot of video games and things like that. I thought financial technology would be extremely boring. That's where data scientists went to die, like they would go and just sit there and stare at a screen, like a green screen from 1980. And then I learned it's absolutely the opposite. They're dealing with the most complex problems in computers, in software, everything you can imagine. They're dealing with it, and they've been dealing with it for a long time. So that has been really my focus, and I have the strong belief that, and I've seen it play out, which is, if you take what you learn in a few industries and you can kind of abstract that away, you can then start to really solve bigger problems. So that's really been my story in a nutshell.
So can you talk about, give us a little background on 3Forge and kind of what its origin story was, because you were one of the founders of it. You're leading it now. Where did the idea for this come from?
Right, sure. So I worked in various capacities in different firms, some very large firms, like Bear Stearns, JP Morgan, so on and so forth. Along the way, I realized that there were a lot of people that were very focused on their particular problem set, whether it was regulatory compliance, whether it happened to be high frequency trading, maybe it was how to store data long term. Even when it was video games, it would be, how do you tend to do a real-time interactive experience? All of these things, it's as though people were very siloed and focusing on that exact problem. But I found that the problem set was 90% or more overlapping between all of them, meaning that as I went and I moved and I tried to get involved with more and more different ways computers were being applied, I could find more and more, I could find similarities that cut across all of that. And then in 2011, I felt that really a lot of time and a lot of money, frankly, was being wasted. A lot of cycles were being wasted on writing and implementing the same solutions over and over again. I felt that there was a real need for basically you could almost call it an abstract platform that provides a lot of the things that people need out of the box. They're not wasting time on glue code and rewriting these basic sort of first principle type of things. And then I could go and sell that platform almost in a consortium style. So that's really was the vision. That's what got me started. Another way to put it is I got tired of writing the same thing over and over again, maybe getting paid a little more each time. And I felt that if I just step back, really focused on the problems, solved them right, then we could go back to industry and sell that. And we have.
So I have a few different questions that I want to ask. So
Sure.
One of the core offerings, I guess is a way to say it, is around data virtualization. Can you talk, and for those out there that don't know what data virtualization is, what is it? How would you define data virtualization?
Okay, sure. So first off, as a clarification, I'll go through this later. There's a few different buckets that the platform focuses on. One of them is around data virtualization. Now, where I think data virtualization comes in specifically is when you want to ask when a human wants to ask a question to a computer and get an answer back around data. And the issue becomes that generally this information is stored in a disparate set of databases, not just physical systems, but actually different types of systems. And so what you really need is almost like a meta layer over that, or as we call it, a data virtualization layer that sits on top of that, and basically allows you to ask the question to that virtualization layer. Sometimes it's called a federated database, for just to be the technical term. And then that basically formulates underlying questions, sends that off, and gets the results back so that you can see that. So a lot of times underlying data stores will store information slightly differently or name it differently. But then as an end user, you want to see a normalized view of that. So the data virtualization layer is really responsible for taking what you're asking, making it conform to the underlying systems, taking those response back, and making the answer conform to what you want to see.
That makes sense. How does that compare to like the term semantic layer? Like I hear that term a lot as well.
Right. I would say that's a similar concept. So you have semantics, you have I would say the schema itself, and then you have the physical data. And so when you put all those together, basically the data virtualization layer is responsible for that mapping. Really, it is often mapping the the semantics. It's also mapping the schema, and then it's also often mapping entitlements. So it's taking all of these sort of things about data and mapping them from one system to another, or one system to many systems.
Mm-hmm. And it's all kind of being done in the spirit of trying to make the data more immediately usable and driving answers to questions, or driving like meaningful use from that data without having to go and interact with that data at the data layer level and like create your queries and stuff like that. You're able to be more inquisitive in how you're interacting with the data. Is that
right? Let me put it this way. I'll take a slightly different tact at this. I've noticed through my travels that data systems tend to be organized based on the structure, almost the organizational structure of the company. Literally, let's say at the top of the organization, you have your CTO, your CXOs, and then they decide we're going to take our company and break it into 3 different products: product A, product B, product C. In my world, in finance, maybe that's fixed income, equities, foreign exchange. I don't know, whatever. It doesn't matter in the industry. You end up dividing those things up, and then literally once at the top level, you start to divide that, and then the people reporting uses support start to divide it. Suddenly, your actual data system basically looks or maps the structure, your organizational structure. But the problem is, just because you've organized, or a company's organized literally their personnel into a certain way, that doesn't mean that's how you want to be able to ask questions of your data. Or another way to put it, it's certainly not what your customer cares about. You know what I mean? The customer wants to be able to ask questions about what's going on with their finances. They're not interested in saying, okay, well, I need to go talk to this group to get that piece of information, and this group to get that piece of information. They want to be able to ask a general question and then get an answer back.
Oh yeah, I mean, what you describe is actually a very frustrating thing for a customer, is that they don't want to have 5 different people they have to chase down for parts of the answer. They want to be able to have a singular point of contact, a singular answer that unites all of the things that they care about, because they're the customer. They have their accounts, and all of those accounts should be, able to be viewed and understood, even though there's different functions. But you bring up a good point, and this is a common theme here on data leadership lessons, is that we have silos and organizations for a reason. It helps grow large organizations. These functional breakdowns are okay. This is essential actually to growing organizations to a great extent. Our data, however, needs to break down and move across all of those different silos and be brought together in a coherent way, that because our technology systems reflect the organizational structure, it's difficult to do in a lot of cases with data. So it totally makes sense what you're talking about in being able to kind of unite that data across all of the different
Mm-hmm.
aspects of a company, because that's really the way a data consumer is going to want to use it. And that's there's opportunities there to look at data from different sections to find business value or opportunities in taking that knowledge that you can gain from analyzing the data and applying it to some sort of activity or decision that can drive value.
Mm-hmm. And actually and it's funny because one of the things, again, going back to the data virtualization layer that we focused a lot on is how important that mapping is. You can throw away the technical terms and all that stuff. It's just this mapping is an absolute necessity because again, if we go back to the very basics, you can't expect an organization to necessarily align all of their data according to what their customers need, as maybe ironic as that sounds. You always think the customer's right, but nor can you expect them to align their data based on what the regulatory body needs, or can you expect them to align their data according to what their business intelligence tools need. The data needs to be organized in the proper way for that data. Some types of data is very columnar, meaning you have many rows and maybe not that many columns of data. Sometimes data needs to be very normalized, right? Because you have a certain set of fields that you understand, like know your customer sort of data, things like that. And then other times, maybe you have audio and video, unstructured data, like this podcast, that also needs to be stored. Those need to be stored in different ways using different types of systems, and different people need to have different vantage points as to how to see that data. So mapping is an absolute necessity. And I think it needs to be something that, and I will go back to, there has been this concept of data lakes, data oceans, data body of water, name you choose it. There's been this concept of trying to put all the data into one place, but the problem is that is always premised on, or that always is driven by a particular need. And I think there's often this sort of this fallacy, this hope that once we get all of our data into one spot, it's going to suddenly satisfy all the different vantage points of everything we need, but it just doesn't work. And I can give an example. I can give example after example, but I think probably one of the most common ones is probably the two most common. One would be a regulatory requirement comes in and data needs to be stored a certain way for a certain period of time. And so they decide to collect all the data, put it in one spot, and it meets that regulatory requirement and not much else. Another example would be senior management comes in and they say, we want to be able to run diagnostics, analytics on our data to forecast, spending, et cetera, P&L and whatnot. And you end up organizing the data all in one spot to answer that question. Ends up not answering your regulatory question or anything else. And so, but I can name story after story or example after example of times that I've seen this. At the end of the day, you need to store the data in the way it makes sense to store that data. It's almost like you have to let the data dictate how you end up storing it, and then you build this mapping on top of it to handle all the different personas.
It's funny because you are a very technical person with a technical company, technical function. And yet up till now in this conversation, we have been talking like squarely about like data strategy and like data management strategy types of things. But you really struck a chord with me on this last segment, because I am on a personal mission to get people to stop talking about the fallacy of a single source of truth. I think that the single source of truth in it is, I get why we want it. I would love to have clear and perfect understanding of things. But the fact is that the reality of our businesses and the complexity of our businesses are nuanced. I use the example, like, what does balance mean in a bank? Balance could mean 50 different things in a financial institution. You need more qualifiers there. And you can think of examples all the time where there's different contexts for a piece of information where it means it's right in one context but not another. What we need is not a single source of truth. What we need is a fully illuminated understanding of that nuanced truth. We need to be able to approach it from different perspectives. It's just like if you're trying to illuminate a statue in a museum, you don't do that with a flashlight. it's inevitably going to cast shadows. It's inevitably going to create things that aren't there. The only real way to get it as close to perfect as possible is by hitting it from many different directions with a balanced amount of understanding or balanced amount of light towards that thing that you're trying to illuminate. And if data is attempting to illuminate truth, we really need a multifaceted perspective that encompasses all of the different directions of perspective that we have, and then we can navigate that more effectively and apply in this circumstance. This is the version of the truth that you really want to be concerned with.
That's right. And I think, if you actually, I think a key word here is organic. If you think about things that are organic, they tend to be able to multiply and be able to be somewhat self-sustaining. So, whether it's trees or forest or the universe, there is no central spot necessarily that you can say has all the information. It has to be able to grow organically. In fact, that's why the internet works so well. Is they had several iterations beforehand, but once they came up with this protocol that said there is no centralized server, because you got to imagine. I mean, I shouldn't say imagine because we know it. When they first said let's have computers communicate with each other, the whole idea was you have a centralized computer that's basically like your phone book, and then all the different computers talk through that. That breaks down. And if we still had that concept today, the internet, we wouldn't be talking. I can guarantee you that. You know what I mean? The internet would not have been able to grow the way it has. The reason the internet has grown is because it was designed by some very smart people to be organic. And we need to think about our data that same way. Because if you're not architecting your systems to allow your data to keep growing in an organic way, then you're eventually going to hit these sorts of issues, and you're not going to be able to ask the questions and the things you need about it.
That makes a lot of sense. It gets me though thinking, because there's a balancing force to this kind of organic growth piece, and that is we often see in our organizations just sprawl where it's growing in different directions, but the value proposition for that growth isn't really there. It's just kind of meandering into growth, but not actually targeted into meaningful growth that's creating a better return on investment. Instead, it's just creating more stuff we have to manage, and oftentimes delivering even less value over time. How do you mitigate that? Like, what can we do from your perspective, like to get healthy growth and remove unnecessary growth or waste that inevitably kind of comes into the system?
Mm-hmm. Well, I'm gonna take a quick aside here, leading up to how I approach that, and I'm gonna say I think one of the things I've loved about being involved with so many different industries and being able to work with some of the biggest and most challenging problems is I've also gotten to work with some really, really smart people that have also dedicated a lot of time working on this. So I think in order to solve these problems, you almost need to step back, look at lots of different types of problems, look for those commonalities, and then come back in and try to attack it. Mm-hmm. So with that said, there's 4 questions I like to ask, and they all start with a V. There's 4 things I ask about. I ask about what does the volume of your data look like? What does the variety of your data look like? What is the velocity of your data? And what is the validity of your data? And by those, I mean volume is pretty obvious. Like, how much data are we really talking about? The velocity of the data is how fast is that data moving? Like a lot of times, especially in high frequency trading, you've got millions of messages a second, but at the end of the day, maybe a lot of that, and it's very important to be able to process that in real time. That's something we focus a lot on, but maybe at the end of the day, you really care about the aggregations of that. So you have to pay attention to the velocity of that data, how quickly it's moving. And then the next ones are the variety. So again, like, what are the different types of systems we're talking about, and how complex is it? How different does the different types of data look like? And then you've got the validity of that data. And so, that's kind of those are the 4 things I kind of like to focus on and then put it into buckets. And sometimes you'll see systems that have a huge volume, low variety, very high validity, it's very accurate, et cetera, et cetera. And then you kind of have to gauge. And then you look at those, you kind of rank each one in a 1 to 10, and then you can sit back and say, okay, this is how we think we should focus on this type of problem. in an ideal world, and I would almost say, a company who's never been through a merger or acquisition and only has a single product, they might have a large volume of data with very little variety, very high validity. And that's a situation where, okay, yeah, use one database, set this up, put it all into one spot. But that's a much less common scenario than we have a large volume with a lot of variety, and the validity isn't so good. In which case now you have to tackle that. Now, the reason I went, you were asking about what do you do is you kind of start getting diminishing returns as the volumes of data go up. And I think there's a few things here. One, I'm trying not to be mean about it, but I think a lot of times there's science projects where people will collect data, and I've always said it's, inserting is easy. It's deleting that's the painful part. No one ever wants to delete anything, but at the same time, you have to be cognizant of, what is really the value of this data. Maybe you hold on to it, but you move it on to some sort of different storage. You don't make it part of the main story, and then we have this concept called drill down, which is one of the big cornerstones of the product. So after you've got your virtualization layer, then drill down becomes the big thing, because not all data has the same value. So for example, let's say we take an airline ticket. An airline ticket actually has many things to it. It has the actual airline ticket, like the person who's flying and the flight they're on, et cetera, et cetera. But then there's this audit trail of things that happen. What time did they buy the ticket? When did they modify that ticket? When did they choose the seat? Did they change the seat? What operator, when they called up, which support person modified the seat for them? So there's actually a lot of information. There's this huge audit trail. That audit trail is not as important as the actual ticket. However, if something goes wrong, or you find something very interesting about a set of tickets, then that might be important. And so this is what we would call a drill down, which says you kind of keep your most relevant information close to the users. And then you have this sort of drill down concept. So as you want to basically dive in to the quote unquote less valuable information, or the less direct information you can. I shouldn't say less valuable, because to me, it's a lot of time the real value is sitting in some nugget off in the corner. But it's not, it almost, you have to have a starting point before you get to that.
Right. No, I think that's all fair. That definitely makes sense. I think too, like I grew up also in the financial industry and in the trading space specifically. And so I've done a lot with like high frequency stuff. I've done a lot with trade reconciliations, massive amounts of value, doing big data before big data was a catchphrase, right? And I really believe that it both was a fantastic way to learn the data space. And granted, like, I don't consider myself a data scientist. I'm more of the data engineering by trade. Like, I like to build the systems, but I like to provide the inputs for data scientists. So I can certainly dabble. But what I also think is that the financial industry broke me in how I think about what's reasonable and what's acceptable, because I'm used to those kinds of million messages a second, or just insane transaction volumes, or insane amounts of calculation where you're creating, net asset values, or risk amounts that you have to deal with on a daily basis, like all those kinds of heavy calculations that you see throughout the financial industry. When you get into some of these other industries, the expectations and the standards can be wildly different, and especially doing things like research and development, or doing things that are operational in nature, manufacturing in nature. Like, what have you seen in terms of like big brushstrokes, like kind of broad patterns between different industries? Or do you see the more you think they're different, the more they turn out to be the same as you dive deeper? Because I certainly don't have that level of depth in many industries.
Yeah. So there's a term I really like, fintech versus the tech fins. I don't know if you've heard that before. I love that term,
No,
right? So you've got the fintech, financial technology, and the tech fins, like the big technology sharks, right? And we started off in fintech. We now work with several Silicon Valley firms. What's amazing is actually how the same problem, it's two very different cultures with a ton of overlap. And I think a few of the differences are, one is when you get into more of we take it for granted a lot of times, except for in a few very specific cases like commercial transactions, where most systems in fintech basically have sessions. And by that, I mean, there's a time that it starts and a time that it stops. So you have, in equities, US, North America, trading starts 9:30, it ends at 4 p.m. So that actually gives you a huge window where you can do upgrades, maintenance, data exploration, whatever sort of things you want to do. Even if you said follow the sun, so we've got all markets around the world, generally it's pretty quiet after the North America close before the APAC or Asia opens. You've got those 2 hours. And then you've got weekends off. If you're foreign exchange, well, you've at least got Sunday off. So you've got time to do those sorts of maintenance and data maintenance and updates and things like that. In Silicon Valley, but again, the transaction and the accuracy has to be spot on. And if there's any issues, this, you have to go back, you have to reconcile it. I could talk about reconciling data for hours. Maybe not the best podcast, but I could.
I'd enjoy it. I think that'd be great content.
Reconciling data, all those sorts of things, it has to be perfectly accurate. On the Silicon Valley side, it's the accuracy is definitely there if you're talking about things like cryptocurrencies and stuff like that. But in a lot of cases, the differentiator is their sessions are 24/7. I mean, in other words, there's never downtime. So anything you're doing, there has to always be this concept of handoff between, system A to system B when you're going to upgrade or something like that. So I do see some differences, and I also see differences in how data is stored. And what's funny is I would say these solutions are very similar, but the actual implementations are different for some reason. Just these sort of technologies I see used in one end, like for example, you might see KX used a lot in finance, which is the first derivatives product, and then but then you move over, onto Silicon Valley, and you might see Redis used a lot more. As an example, I'm just throwing that out there. So, a lot of times they're just slightly different. They're just, both wanting to store data. They're just using different types of systems because they're kind of coming from different backgrounds. But more and more as we go down this path, and I say we, I mean just computer scientists, data scientists in general, the two are converging. I think absolutely. And I think one thing to maybe put you at ease a little bit about thinking that fintech broke you, the way I look at it is I think fintech has been at this problem for about as long as any industry. I mean, when I look at it, it's like, well, we built computers probably for war, unfortunately, and then once that was over, then we used them for business and for accounting and for finance and things like that. So we've been dealing with this, and we've been dealing with what it means for electronic systems to create data and fight each other and all of these sorts of things, and managing huge sets of data longer than just about any other industry. So it's always easy in the beginning when you're starting from a greenfield, fresh sort of thing. Yes, I mean, you have one database, you can kind of think about how you want to build it, and then you start acquiring other companies and this and that. And before you know it, you've got this very complex technology soup, and now you're basically back to where fintech has been for a very long time. If anyone's been paying attention for the last 20, 30 years has seen a lot of companies merging, a lot of new technologies coming out. It's a very competitive industry, so people are always looking for the greatest technology to push, their company forward. And so I guess my point is that fintech just has had these problems first because they've been around the longest, but I think all these other industries are seeing it.
Well, and I would add to that too. I think in the fintech world, you had such a direct correlation between your technology and data sophistication and your competitiveness, because so much was being driven through electronic trading directly. It was that technology sophistication, and if you could lower your latency, or you could get to the market quicker, you could do your analysis faster, you had a direct competitive advantage in that space, which is where you got all of this investment to go. It gets me thinking though, because as you were talking about some of the developments of computers and technology and fintech and that, I think about Internet of Things. Internet of Things was 5 years ago. I'd have a conversation about Internet of Things, and the thing you would think about is like the Twitter-enabled refrigerator, which is just a silly idea. Like that's a terrible use case for that, but that's what we were thinking about at that time. It's like, oh, the refrigerator that can order my milk for me or whatever. But now you start thinking about all of these devices, and you see all of the wearables, the watches, the Bluetooth trackers. You've got all of these voice assistants all throughout your home listening to you. Like that world has evolved quickly. What's the
Mm-hmm.
state of Internet of Things and data, and like where do we stand today really, and where's that heading? Like what are your thoughts in that space?
Well, I think so. So I'd agree with your general trend that yes, it was a big thing, and everyone thought it was going to have immediate impacts. And by the way, a lot of times, at least my experience has been, and I think most people would agree that a technology comes out and you think it's going to have some radical change in the beginning, and it goes in a direction kind of no one saw, but it ends up having a huge impact, just not in the way that we forecast it would. So, I think the same thing with VR. I think VR eventually will, machine learning, all of these things are having impacts just in different ways and a different timing than people expected. Same with IoT. I think IoT, first off, what IoT is enabling, is the ability to basically commoditize sensors, sensory data, and the communication of sensory data and things like that. I mean, it's been completely commoditized now. So it's very cheap to build these things. I mean, you look at a car, how many sensors and pieces of information are in that. And the fact is, I mean, we've done this. You can now take, you can take our software and attach it to one of these smart cars. And basically you're receiving a live stream of just unbelievable amounts of information, everything from like the position of how much the windows rolled down to what's the speed of the car, et cetera, et cetera. So everything is now available, and I think we're now at the stage where everything's been commoditized. The idea is, and I think most people know this, and I'm just using an analogy, like when you turn the steering wheel in your car, it's not physically like turning a shaft that's turning the wheels, right? They realized a while ago, for safety reasons, but probably cost effectiveness reasons, it's better to actually have sensors. Those sensors talk to a computer. The computer sits in the middle, and then the computer is basically turning the wheels, et cetera, et cetera. And all of this concept of having the computer sit at the middle, we've now done that, and we're there. And now I think the next step, as with most cases, after you get the computer in the middle, is to now start to tap off that data and look for interesting information. And we've only done this in, I would say, probably the most important, but only the most, I guess, essential ways. Like we are now definitely using that information for navigating, for like Google Maps, things like that. We're now focusing on, yes, where's your position? What's the traffic like in other areas? It's amazing what they've done with that, but I think there's way more that can be done. And I think that really this is now going to, once again, like everything else, it's going to become a data, or as I like to think of it, information challenge. We're producing tons and tons of information, way more information now than we could possibly deal with. And I'll go back to one more analogy here, which is I realized something when I was dealing with in finance, which was if you had humans on either set of the equation, on both sides of the equation. So let's say two humans are trading a stock. That only produces so much information. Humans can only do so much. We only produce so much information. But then once high frequency trading came around, and there's many other analogies I can draw to that, but high frequency trading basically said a computer is going to fight another computer for the best price possible, right? Yeah. And once now we're talking to computers, that's when the data explodes, because computers can produce data at literally millions to billions of times a second. Humans cannot, at least not in the sense we're thinking about it, right? So once you've got computers talking to computers, now the amount of data goes way up. And if you were to actually dive into any one of these investment banks and say, how much data do you have here? How much data do you have there? And then you were to basically look at like their dark pool as an example, which is basically how they internally cross orders. I know I'm getting a bit technical here, but as soon as you take a look at that, the volume of data is massive because that's computers interacting with computers. Likewise, when you get into IoT, now you're talking about computers talking to computers, right? Even if you're not at home, and let's say in the future you have something set up so that if the temperature in the house drops below this degree, then the refrigerator should do this. I mean, that's maybe something you could do for energy efficiency as an example. That means these two devices are now talking to each other probably all the time. Even if you're not at home, even if you go on vacation, even if you're not opening the refrigerator door, those are conversations that are still taking place and still generating information. Anyways, all this is an analogy to really say that the amount of data is now exploding. And now we have to start to be very judicious about what information we want to hold on to, not. And this is where I think the ability to drill down to interesting information becomes essential, because an exception management becomes a critical part. And by exception management, I mean most data is just straight through processing. The data comes in, the data goes out. It's not that interesting. It's old hat. Then when something interesting happens or an interesting trend, now that flags something that either human or computer needs to look at. And when you look at that interesting nugget, now you need to drill down to see why that actually happened, right? There's a crash on Highway 95. I'm just picking that because there was on as I was driving to work. I normally take public transit, by the way. And so there, there's an accident, but now the fact that there's an accident, that's an exception. I'd like to think it's an exception, anyways. I got to stop. That's an exception. But now you want to drill in and see where that accident was, who was involved in it, were there other people, is this going to affect other things, et cetera, and start to look at that. So the point is, exception processing says, something's happened. Now we need to be able to drill in and look at the underlying information and react and handle that exception. Yeah. So I think that's where IoT is going to have a huge impact.
Yeah, well, I really like, the stories on the personal side, like we can all relate to. Like we see these different devices, we see these different situations. I think the traffic example is another good one where you're thinking about everybody who's using a GPS is now thinking about, okay, how do I route around this traffic or what have you? So this prevalence that we see this in our personal lives is great. It's there. There's a lot of people working on it. But I think one of the things that you've touched on that I just want to emphasize too is that in our business context, what we're seeing is more and more things happening in the workplace and in our businesses where similar kinds of data explosions are starting to happen, where our businesses are not necessarily designed to be or thought of, especially by some of our senior leadership. They don't necessarily think of, oh, we're a data business first. I'll never forget when this is a few years ago in consulting, we're thinking about, there was a company that manufactures ironing boards. And like they were using machinery that was built in the early 1900s. They were like, this is as anti-data as you could think of, until they installed a bunch of sensors in their manufacturing plant. And all of a sudden, when that happened, they realized, hey, we now can maintain these 100-year-old machines with sensors that we've added. And now we all of a sudden have to build all this analytical capability that we've never had before, that we didn't hire for, that we haven't learned. We had to teach a bunch of people. All of this stuff had to happen. And that was like the least data-driven company in the world turning on a dime because they realized their manufacturing operations were deficient, right, because they weren't leveraging the sensors. And that was like everywhere.
Yeah. I would be as bold as to say there is no concept of not being an information-centric anything. The more I mean, I kind of like to dabble in physics on the side, and physics will tell you that we're pretty much everything's information. And it talks about that a lot, and I'll spare the details there. But then, it just every once in a while I'm working on a problem and then I realize, wow, this really is just about information. In fact, you can go back to what separates humans from other species. I mean, it's the fact that we can communicate with each other. Yeah. If we were just as smart as we were, if humans were the only thing that separates humans today from 1,000 years ago is that we've been able to carry information from generation to the next, from person to person, have these conversations, grow. Everything is information. So any business that thinks they're free from having to think about information, there's going to be another business in their space that does acknowledge that that information is a big part of their business, and they're going to excel at it. It has to.
Yeah.
I can't think. I mean, maybe if I really, really worked at it, I could think of a line of business or anything that information doesn't matter. But nothing's coming to mind.
Yeah, that I think that's interesting. Well, in the interest, I know we're about out of time here, but in the interest of communication and carrying the information forward, what's
Right.
the best way for folks to reach out to you after the show or find you out there?
Yeah, absolutely. So first off, our website, threeforge.com, that's where we talk about the platform, really the core concepts and the way the product works. And by the way, we didn't talk about the platform much today, but I'm almost glad. I'd rather have these types of data conversations anyways. But yes, if you're interested in the product that we built and how we tackle information problems, visit us there. Our social media, really, we focused it on LinkedIn. So if you go to LinkedIn and then you look for ThreeForge, follow us there. One thing is our platform, we have adapters to different types of databases. We have hundreds of different adapters. We've integrated just about every type of database there is, every different flavor. We've seen them all, and whether they happen to be streaming or static, whatever it happens to be, data entry systems. And so we're always kind of focusing on that. We're updating our website and talking about our recent findings and things like that. So yeah, definitely follow us on there.
Outstanding. Robert, thank you for being on the show today and sharing your wisdom with us.
Yeah, absolutely. Thank you.
And thank you all for joining us today. As always, you'll find more information and links in the show notes. Go to dataleadershiplessons.com to subscribe and check out our past episodes and accelerate your journey with training at dataleadershiptraining.com. If you're enjoying Data Leadership Lessons and are interested in electric vehicles, check out my new podcast at electricdrives.us. We give you the information you need to transition to your electric vehicle future. And as always, stay safe during these unusual times and go make an impact. Thanks, everybody.